Today's lesson is about graphing trigonometric functions, and we're going to follow a lot of the rules we followed before with transformations, since we learned how to do those yesterday. So we're sketching them involving transformations. We just need to make sure we watch out for what the four values are, what they do, and then know our parent table. So it says, if each function shown below starts at 0 and finishes after 3 cycles, determine the period, amplitude, equation of axis, domain, and range. I don't really understand what finishes after 3 cycles is indicating here. It doesn't seem to be relevant, but let's say I don't know. Anyway, let's go through and see what we see. So right off the bat, you can see A is 2, K is 1, D is 0, C is 4. Remember, if this were D, then it would have to be in a bracket, sine x plus, so it would have to be sine bracket x plus 4. So here, this thing out here is a C. So what do we need to write about this? The amplitude is equal to the absolute value of A, which is just equal to 2. The equation of the axis is y equals 4. The period is 360 divided by k, which in this case is just 360 since the k value is 1. And then it says the domain and range. So the domain is x is in the real numbers. There's never any restrictions in these functions for x unless, now I understand why it finishes after 3 cycles. It starts at 0 and it finishes after 3 cycles, which means we need to cut it off at 1080, right? Because that would be, let's just put in a bracket, each cycle is 360, so 360 times 3 is 1080, right? So that's why, sorry, I get what they're doing now. You would want that restriction there so that you can specify what to draw. If so again, the function itself doesn't have a restriction, but again, like previous units, you may have restrictions in these questions for various reasons, right? Because let's say we're modeling a Ferris wheel and we're only on the Ferris wheel for 3 rotations or something like that, then you would cut off the equation at the appropriate place. Anyway, it's not a mathematical reason to do it, it's just an arbitrary reason, but those reasons exist. Now, this is kind of interesting. The range. I know the range is less than or equal to y is less than or equal to something, but I actually don't know what those numbers are. Let's come up with a little formula here. The minimum value is equal to C subtract absolute value of A. The maximum value is equal to C plus the absolute value of A. Where is this coming from? This is coming from the idea that if you are on the axis, already, so like y equals C, you can move up a maximum, so you can move up A units, and really I should say absolute value of A, because even if A is negative, or down A units. So to get to the maximum, try to think of it as, okay, if my axis is at 4 and my amplitude is 2, then the highest number I could possibly get to is 6, right? Highest number I could possibly get to is 6. My axis is at 4 and I can go 2 higher. On the other hand, the lowest number I could get to, my axis would be 4 and I could go 2 lower, right? So there you go. Okay, so just if you need to go the other way around, you have that option. Okay, domain and range, so we got everything we need there. Okay, we're supposed to do the same thing here, so let's quickly fire through that same task. So here, our A value is 3, our K value is 2, our D value is 90. Again, remember that you can't have it written in the format they have it here. Really, we should change this equation to 2 bracket x minus 90 minus 5, right? So that you can more easily see what's going on there. Now, okay, so let's write down what we know. The period is 180, 360 over k. The amplitude is the absolute value of A, which is 3. The axis is y equals negative 5. The domain is x is in the real numbers, such that 0 is less than or equal to x is less than or equal to, now this time I have 3 times 180, which is 540. Okay, so I'll put it this way. I'll put 540 and I'll put in brackets 3 times 180. Because, you know, it's still 3 cycles that we're drawing. Each cycle is 180 it takes to complete, so x is anywhere between 0 and 540. For range, we have y is in the real numbers such that, okay, let's see. -5 is our axis. We could go 3 higher and 3 lower. Okay, so -8 would be the lowest number you could reach, and the highest number you could reach would be -2. Okay, so somewhere in between -8 and -2. Now, the d value actually doesn't do anything here. If you want to, you could say phase shift 90 units right, but it told us the graph starts at 0. So it isn't going to change where the graph starts and finishes. We weren't even asked to do the phase shift anyway, so I'm just going to put it down just so you know it, but it doesn't ask for it. Okay, one more of this type of thing. So amplitude, or A is -4, K is 0.5, D is 360, C is -2. Again, let's just show where I'm getting that from. The correct way to write this one would be 4 sine 0. We have to factor out the 0.5. That doubles the 180 to 360, and then you have the -2 at the end. So again, the amplitude is equal to just 4, which is the absolute value of A. The period is equal to 720 because it's 360 divided by K. The phase shift is 360 to the right. The axis is y equals -2. The domain is x is in the real numbers such that 0 is less than or equal to x, which is less than or equal to 2160, which is 3 times 720. And the range, y is in real numbers such that, let's see here. So our axis is at -2. We can go 4 up or 4 down. So -6 is less than or equal to y, which is less than or equal to 2. Okay? Now, here we have to actually sketch. Now, sketching, you know what to do with this in the sense that you have to make the parent. So let's start just by making the parent table. And so our parent function is sine x, so we'll go x and sine x, or x and y, whichever you want. The parent function for sine x from yesterday looked like this. X counts up by 90, and y starts at 0, goes up to 1, back down to 0, down to -1, and then ends up back at 0. You need to transform that equation with a being 3, k being 1, d being 0, and c being -2. So, I mean, this is not super difficult. I guess I got an idea. Why don't we do this? Make a meta table. Doesn't like that, does it? Okay. Let's try columns then, I guess. Pause this. Okay, so in the middle column, let's go all the x coordinates just become x, all the y coordinates become ay, 3y minus 2. Okay, so x translating to x, obviously very easy, there's nothing I need to change here. For y, all my zeros become -2 because that's where the axis is now, and all my 1s multiply by 3 and then get subtracted by 2. So actually this one stays where it is because 1 times 3 is 3, take away 2 is 1 again. But this one, -1 times 3 is -3, take away 2 is down to -5. So you have those 5 points. Okay, so let's quickly plot those points here. So we have, what was it, 0, -2, 91, 180, -2, 270, -5, and then 360, -2. Now, one of the things that's challenging about this is how to, so there's two mistakes people normally make. Number one is, what do I count by in the x-axis? So it says sketch 1 cycle. That means whatever you have here in your transformed function needs to fit on your graph. So I would say if you count by 30s, so let's make a note here. If you count by 30, you need 12 boxes to complete one 360-degree cycle. So let's suggest for now, since 12 boxes is no problem on this graph, we can fit that. So let's count by 30. Okay. So I'm going to change mine so that it counts by 30. So basically on your graph, your 1, 2, 3rd box would be where you draw B. 1, 2, 3 boxes over, you draw this point. 1, 2, 3, you draw this point, and then 1, 2, 3, you draw that point. So the first mistake people make here is they don't count by a logical number. In general, 30 is a good number to count by, but you have to make sure that whatever your transform table shows is going to fit. So I might be able to get a better explanation of this when we go to this part here. So for now, let's just say, okay, I'm going to count by 30s unless I have a good reason not to, and that's that. Now the second mistake people make here is they draw this. So I think what I want is pen. So this is what people do when they plot these points, they get it perfect, and then they do this. And that's wrong. Okay, you cannot draw that, and that's a sine curve. It's not a sine curve. This is like an absolute value, like really sharp corners type of thing, right? What you need to draw, obviously we're not perfect drawers, but to the best of your ability, you draw something that looks like a circle, a half circle there, and then a half circle there. And even here, I did not do an especially good job with this. I would probably, I mean, I don't have the benefit of working with, something like that is fine. As long as I can see it's rounded and you haven't drawn like a heartbeat monitor, right? Like it shouldn't look like that. Again, when I actually draw it, so what was the equation we had to draw? It was 3 sine x degrees minus 2. My graph is certainly not perfect. It's too wide here. It's not bad here, but it's not tall enough. It's not symmetrical. Like, I'm not going to take off points for these things, but I will take off points for just drawing jagged lines. So don't draw jagged lines. Okay? So rounded to the best of your ability is what it should look like. And again, we're only drawing the one cycle. So really what I should draw is function f between 0 and 360 only. And that's what you get. Okay? So that's what your picture should look like, more or less. I'll put this in. Okay, so I'll just paste this into the document so it's here if you want to look at it. Okay, so that is our example of drawing an equation. The amplitude is oh, I see. I'm not easily going to be able to fix this. Well, I guess I'll just type it. Amplitude is 3, period is 360, phase shift is 0, vertical translation is 2 down, reflection in x is false, the domain is x, 0 is less than equal to x is less than equal to 360 because we started it at 0 and stopped it at 360. And the range is, I got the -5 was as low as we got, which is less than equal to y, which is less than equal to 1. Okay, so I'll do that. I'll just wipe this out. Okay, next one. Now for the next one, the a value is -3. The k value is 0.5. The d value is, again, you need to factor this. So the d value is -180, right? When you factor the 0.5 out of it. And then the c is -1. So let's copy paste our transformation table because it's basically the same thing that we need to do here. Okay, every x is going to become x over k plus d. So every x is going to become x over 0.5 minus 180. So again, an easier way to write that is 2x minus 180. Okay, again, just so I can show you, let's put it just underneath over here. So when you factor this one correctly, you get 0.5, then x plus 180 minus 1. Okay, like that. So that's where I'm getting d is -180 from. Now, okay, so that's good. And then the y, all the y's need to become ay plus c. So a is -3 this time, and c is -1. So again, if we start at 0, we get -1. If we get 1, we get -4. 0 is -1 again. -1 is actually +2, right? You have -1 times -3 is 3, and then take away 1 is 2. And then you have 0, which gives you -1 again. Now the x's are a little trickier because we have to double them, and then we have to subtract 180. So 0 doubled is still 0. Subtract 180 is -180. Okay. 90 doubled is 180, and then subtract 180 is 0. 180 doubled is 360. Subtract 180 is 180 again. 270 doubled is 540. Subtract 180 is 360. And then 360 doubled is 720. Subtract 180 is 540. So we have this. Now notice x should always count up uh, 90 over k, right? So in this case, 90 over 0.5, which is 180, right? So you notice x counts up by 180, and that's another way that you can do this. Now, a problem with this graph you should notice right off the bat is that the first point we need is -180, and we don't have a negative side to the axis. So there are two ways you can solve this. You can add a point over here if you want. That will work fine. Or you could get the next point. And the next point in the cycle would be 720, because we add another 180 there. And then we go, we just repeat the cycle, right? Like these 1, 2, 3, 4 points just keep repeating. And so it would repeat again. So I don't know if we want to do that really. I think it's fine to just draw what we have here, and we'll just start it over there. You'll just draw a point somewhere over here. It's fine. Okay. So again, what to count by? We need 720 worth of space since t equals 720, and we're supposed to draw one cycle. So if we count by 60, we need 12 boxes. So let's count by 60. By the way, if you take the period, yeah, see, I'm not sure what a good way to do this is. Let me come back to you with that. For now, let's say, count by 30 unless k is less than 1. Then count by 30 over k. But even this is kind of bad advice. Let's just leave it. I think you'll just have to figure. I can't think of a good, easy way to always be right here. So I would just say recognize how much space you need and then count by a reasonable number to get there. Your options are 15, 30, 45, 60, 90, 180, or 360, I would say, are typical options. So, you know, if you were counting by 60, you'd need 12 boxes. If you're counting by 90, you'd need 8 boxes. If you're counting by 360, you'd only need 2 boxes, which would be kind of silly because your whole thing would be crammed into just a tiny little bit of this. So it's a trade-off between you want to use the space so it's not too crammed, but you don't want to be counting by such a small number that you need, 50 boxes to complete your picture. In any case, in this case, let's just count by 60. So if we count by 60, we need 12 boxes, so let's just do that. By the way, how did I get that? I did the period divided by the increment. So the increment is what I'm counting by, equals the number of boxes. So in our case, 720 divided by 60 equals 12 boxes. And then that's how we figure that out. In any case, when you draw this one, so let's just plot the points first. So we started with the point, oh, that was not so smart. Negative 180, 80, and negative 1. Then we had 0 and negative 4. Then we had 180 and negative 1 again. Then we had 360 and positive 2. And then we had 540 and negative 1 again. Okay, so when you look at this, okay, your graph should look sort of something like this. Again, I would suggest you count by 60s so that each box, like every 3 boxes, you're drawing a new dot. Right? So A, 1, 2, 3 boxes, B, 1, 2, 3 boxes, C, and so on. Right? And then you just connect them together. And again, you do your best when you're drawing them to, make it nice and round and just avoid a sharp corner, right? So when I draw this one was negative 3 sine 0.5x plus 90, and then it was in degrees, so make sure I put it in degrees, and then minus 1. So you can see what you're supposed to look at is pretty close to what I drew. And then let's draw a function f only between negative 180 and 540, so that it just draws the one cycle. Okay, so your graph should look something like this time. Okay, so we'll just paste it here. I'm not going to bother going through the period and phase shift and all that stuff. If you have a question about that, you can ask, but just do the same thing we did up here. Okay, this last one, again, it's just more of the same. Let's do the transformations, but let's not bother graphing it or looking at this thing at the bottom. I'll do the transformations with you, though, because it's a cos, and that's a bit different. So this time, okay, let's look at what we've got. So the A value is 0.5. The K value is 0.5. D, they actually put it in the right format for us, so we'll leave D as negative 60, and C is positive 2. So all our X values have to be divided by 0.5, and then we have to sorry, I just want to make sure I didn't make an error up here. And then we have to subtract 60. Okay, so we go 2x minus 60 would be our transformation equation for x. For y, it's it's ay plus c. So the a is 0.5, the c is positive 2. So we have that. Y's are easy. All the axis points you can type in first. 2, 2, and 2. Oh, no, I'm sorry. Right. Sorry. Thought we were working with sine again. We're not working with sine. We're working with cos. Okay, sorry. So let's fix this first. Fix the parent function. Now cos starts at its maximum. But as long as you can remember that, you can remember the rest of what it does. It starts at its maximum and it heads down. Before it gets to negative 1, it has to hit 0. Then it hits negative 1. Then on its way back up, it hits 0 again. And then it ends at its max, which is where it started. Okay? So now, when we're talking about cos, okay, the axis values go here and here. And I can see the axis in my question is 2. The maximum, or the number 1, when you multiply by 0.5 and add 2, you get 2.5. 1.5 would be the minimum. 2.5 would be the maximum again. the x coordinates have to double and then subtract 60. So 0 doubled, subtract 60 is 60. 90 doubled is 180, subtract 60 is 120. 180 doubled is 360, subtract 60 is 300. 270 doubled is 540, subtract 60 is 480. 360 doubled is 720, subtract 60 is 660. Again, notice that the x's have to count up by 90 over k. They count up by 180, the same as they did in the last question because k is the same. Once again, I need to draw 720 worth of space in the x, and if I count by 60, it will take 12 boxes to do that. If you count by 30, it'll take 24 boxes. It might be a bit tight, right? You might have to extend it a little bit this way and that way. Let's count by 60. Again, it's perfectly fine for what we're doing. So again, plotting the points here. The points were, so let's delete this, change this point. So this was negative 60 and 2.5. This was 120 and 2. This was 300 and 1.5. This was 480 and 2 again. And oops. And then this was 600 and 2.5. Okay, so again, what does this look like? We'll just draw the scale out a little bit so it's more obvious. Now again, it's easy to draw cos wrong, because when you look at this, your natural instinct is going to be to draw that, and that's not right. And never mind the fact that I didn't even go through the points, but the shape is not right. Cos, okay, you will always draw cos correctly if you can remember that it's kind of flat here, and flat here. So it kind of like it rounds and comes down, and then it rounds off of this and comes up, and then it ends flat. It does not end sharp. It ends rounded off. Okay, and if you can remember that, then you'll be fine. So this was 0.5 cos 0.5 x plus 60 degrees plus 2. Right, and again, my points are perfect. My drawing is obviously not perfect, but it's not bad. And you can see, oh, no, I'm sorry, I did make a mistake in my drawing, sorry. It's supposed to end at 660, not 600. Sorry, I just forgot that. Okay, so yeah, it should end there. It's at 660. So again, let's draw a function f from negative 60 to 660. So we just get the one cycle, and you get what the shape of a cos cycle looks like. Again, just don't draw anything jagged, and you'll be fine. Okay, so that's what that one looks like. Again, I'm going to ignore the box at the bottom. I think you can do that. Determine the range for this function. Okay, so it's easy. The amplitude is equal to the absolute value of a is equal to 2. The axis is c, which is equal to negative 1. The maximum is a plus c. The minimum is, well, let's put it the way we wrote it before. So c plus a, and the minimum is c minus a. So you get the maximum is negative 1 plus 2, which is 1. The minimum is, minimum is negative 1, take away 2, which is negative 3. So the range, you just say y is in the real numbers such that negative 3 is less than or equal to y, which in turn is less than or equal to positive 1. Okay, pretty straightforward. Finally, if the function starts at 0 and finishes after 2 cycles, sketch this and then show the period, axis and all the rest of that stuff. This is a good one because it's challenging us a little bit more. Okay, so let's do the same thing we did to sketch. So start with the numbers you know. A is negative 2, K is 2, D is 0, C is 2. Okay, so that's what we know. Let's go back to our transformation table and let's get our transformations going. So our parent function is sine x. We know sine x starts at 0 and heads up. Then it has to go back to 0 before heading down, and then back to 0. Okay, every x we need to do x over 2 plus 0, which is just x over 2. Every y we need to do negative 2y plus 2. So just what we have there is good. So every x we have to divide by 2. So we start with 0, then we go to 45, and then we go to 90. Then we have 135, and then we have 180. Again, notice that x is counting up by 90 over k, 90 over 2. So every x is counting up by 45. Okay, which it is. Now the sine. We need to multiply the number by negative 2 and then add 2. So 0 times negative 2 plus 2 is 2. 1 times negative 2 plus 2 is 0. 0 again gives you 2, because 0 is the same thing as it was above. Same thing there as well. Then here we go, negative 1 times negative 2 is positive 2, times 2 is 4. Okay, so that's our table. Okay, now the challenge here is it says we need to draw 2 cycles. Okay, so we need to draw 2 cycles. So let's see how would you draw 2 cycles. So here's what I suggest. Actually, let's stretch it out. Okay, so we had the following points, right? We had 0, 2. We had 45, 0. We had 92. We had 135, 4. And then we had 180, 2 again. Now, again, one of the things about what to count by, it's often good to count by d. And now, let's say this. Let's say count by a number that can easily represent d. So, for instance, if d is equal to 60, count by 30 would be okay, right? Count by 30 or 60. If d equals 45, you probably want to count by 45, because otherwise d is going to wind up in the middle of a box. Again, I can't really give you a solid rule that's always true about what to count by, but I'm trying to give you some of the constraints that you should be thinking about. In this graph, I want every 45 to be easily found because I'm counting by 45s in the picture. So in my graph, what I'm going to say is, let's do some considering here. I need to be able to count from 0 to 360, and 360 because I have to draw 2 cycles of 180 each. I want to count by a number that easily expresses 45. My options are 45 or 15, because 15 would work, right? Because every 3 boxes would be a 45. Okay? I could also count by 22.5, in which case every other box would be 45. So I basically, I count 2 boxes, I get to 45, I count 2 boxes, I get to 90, and so on. Let's make a quick table. If I count by 1, 2, 3, I will need. So if I count by 45, 22.5, or 15, I will need, here I would need 8 boxes, right? 360 divided by 45 is 8. Here I would need 16 boxes. Here I would need 24 boxes. So how many boxes do you have here? I count 18 boxes, right? So you have a couple of choices. You could add a few more if you want and count by 15s, but let's count by this one because I have 18 boxes to work with. So every other box I will label as 45, and I'll leave the ones in the middle blank, since it's going to be hard to fit the number 22.5 in there. So on your graph, it would look kind of something like this. So I'm not sure I can get this to work exactly right, but let's try. Count by 22.5, okay, and then I'm going to compress it in so that we don't actually see the 22.5s. You know what I'm saying? So 22.5 is here, but I'm just not going to label it. I'm going to count 1, 2 is 45, 1, 2 is another 45, 1, 2 is another 45, and so on. Okay? Now, how do I draw the second cycle? Okay? To draw the second cycle, so you already have the first cycle. It's here, right? So you have a dot, 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 dot. Now, you take each point, you take the first 4 points, and you move them over by a full period. So a full period here is 8 boxes, right? Because 1, 2, 3, 4, 5, 6, 7, 8. So I take A, I move it over 8 boxes, it gives me E. So what I'm going to do here is I'm going to make a little vector, 180, 0. Sorry, okay, never mind. Let's call it T for period. But lowercase t. Okay, now I'm going to draw a vector A plus T. And you can see that where is point A in the second cycle? Well, it's located at E, right? Where is point B in the second cycle? Yeah, that would be located at B, right? It would be located over here, right? So what I'm basically trying to show you here is if you just push all the points over one complete cycle, and one complete cycle, by the way, is 8 boxes. So we'll do another one, C to C plus T, and then a final one, or sorry, 2 final ones, D to D plus T, and then lastly E to E plus T. And you kind of find out where all these ones should end up, right? So D plus T ends up there. Let's give it a name so it makes more sense here. So D2, okay, C2, maybe I'll get rid of the vectors there, maybe not making this as easy to understand as I hoped. Okay, B2, and E2. Right, so all I'm doing here is I'm just moving E forward 8 boxes. So where would it be on the next cycle? Because the next cycle has to repeat whatever we just did, right? So this was sine, what was it, 4x degrees plus 2, and then this was -3, -2. Sorry, I've got the period wrong here because... Sorry, it's 2, not okay, there we go. Okay, so that was what we were supposed to draw. And you can see that the second cycle, all I have to do to get the second cycle is just move every one of these points over. So I take A, move it over. I actually already have that point because of how we drew the first cycle. B, I move it over. It becomes the new minimum. D, I move it over. It becomes the new maximum. You know, C, I move over. It becomes the axis. E, I move over. It becomes the axis. And so you get this. So you just, all you have to do to create another cycle is just sort of like move all your points over by one period, and you'll get what you need. Okay, so I'll put a picture of this here, and just underneath it I'll say, to draw the second cycle, take each of your points and move them to the right by one period. In this case, I moved each point over 180 to the right. And that's how I, you know, B moved over, A moved over, and so on, right? And that's that. Okay, so that's everything to know about sketching these things. Tomorrow we're going to work on solving problems with them. And yeah, any questions? Please post.